Imagine you are working on a totally top-of-the-line machine. You have 32 gigabytes of RAM, a massive solid-state drive, and, well, processing power that honestly would have run an entire server farm a decade ago.
Absolutely. A total beast of a computer.
Right. So you load up a local data set, you type out a single data query, hit run, and suddenly your browser tab just completely freezes.
Ugh, the worst feeling.
It really is. And then a few seconds later, it just crashes. But here's the crazy part. Your computer isn't actually out of memory. Your processor is like barely breaking a sweat.
Yeah, but your browser thinks the world is ending.
Exactly. Why does the software we rely on every single day secretly put this huge chokehold on our hardware?
It is honestly one of the most frustrating experiences for anyone working with raw data. And I swear it usually happens right when you are on the verge of a breakthrough.
Oh, without fail. Well, welcome back to the Deep Dive. I am Alex Martinez.
And I'm Sarah Chen.
And today we are digging into datok.eu. Specifically, we're exploring the custom SQL capabilities and raw data control inside the Analyze module. Our mission today is to take you from writing these complex, bare metal queries to actually presenting beautiful, executive-ready dashboards.
It's just such a satisfying journey.
It is. But before we get deep into the technical weeds of browser limits and file systems, I did promise to kick things off with a classic. Are you ready for this?
Oh, no. I am bracing myself. Let's hear it.
Okay. A SQL query walks into a bar, goes up to two tables, and asks, "Can I join you?"
Wow. That is terrible.
I know.
No, but I mean, I will admit, it is exactly the kind of optimistic, fun tone we need for today.
Right.
Because, while database architecture can feel incredibly rigid, what we are talking about today, building real-time visual dashboards from absolute scratch using entirely local data, is a deeply creative process.
It really is. And datok has all these fantastic drag-and-drop pivot tables and charting tools.
Yeah, which are great for quick insights.
Totally. But today is really for the listener who wants to bypass those prepackaged tools and, speak directly to the database engine. We are trying to balance the physical realism of local hardware limits with the pure freedom of absolute data control.
That tension is fascinating to me. Because datok operates entirely on your local machine using the browser, there is this constant push and pull.
How so?
Well, you have the ultimate privacy of having your data local, okay? But then you run into the strict physical boundaries of your computer's memory architecture.
Right.
Understanding those boundaries is exactly what separates a good analyst from a truly great one.
Okay, so let's unpack this. We're starting in the Analyze module, specifically looking at the custom SQL console. If using a drag-and-drop pivot table is like driving an automatic car, the custom SQL console is driving a manual transmission.
That is a great way to put it.
Yeah, it's built for operations that require custom transformations or, intricate multi-table joins, basically specific logic that goes way beyond standard grids. But there is a massive, completely non-negotiable guardrail in place.
Yes. The custom SQL engine inside the Analyze module is strictly restricted to select queries only.
Meaning, I can only ask to view the data. I can look, but I absolutely cannot touch.
Precisely. Any command that attempts to modify the database state is intercepted and completely blocked by the engine.
Oh, wow.
Yeah. If you try to run an insert command to add new rows, or a delete command to scrub messy data, or, heaven forbid, a drop command to delete an entire table, the system just stops you dead in your tracks.
I've always thought of it like a strict museum tour. You can look at the historical artifacts with a magnifying glass, you can count them, take photos, but you absolutely cannot pick up the artifacts or move them around.
Exactly.
But I do have to offer a little pushback here.
Okay, let's hear it.
If I am working totally locally on my own laptop and the data is stored in my own local folder, why lock me out of modifying my own files? I mean, if I want to accidentally break a vase in my own private museum, shouldn't I be allowed to?
It's a completely fair challenge. If the data is yours, why the training wheels?
Right.
But the restriction isn't about babying the user. It really comes down to the fundamental architecture and philosophy of the software.
Okay, how so?
The Analyze module is intentionally designed as your presentation layer. It's kind of the equivalent of a read replica in traditional database architecture.
Got it.
If you need to modify pipelines, clean data, drop columns, or insert records, datok handles all of those structural changes over the prep module.
Oh, so it is enforcing a strict separation of concerns.
Exactly. Imagine you are deep in a complex train of thought. You are writing this massive 200-line query to calculate year-over-year retention metrics.
Sounds intense.
All right, and you've been working on it for an hour. If you highlight a few lines of code to test them, and your cursor accidentally catches a ddrop table command from an earlier experiment.
Oh, no.
Yeah. Hidden execute would nuke the physical SQLite file. You would lose hours of data conversion work instantly.
That would be absolutely brutal. So by locking the Analyze console to select only, I am basically guaranteed a safe sandbox.
Exactly.
I can query as aggressively as I want, run the most chaotic nested subqueries, and never have to worry about corrupting the underlying database.
It acts as an unbreakable safety net. But, as you probably know, staring at a completely blank SQL console presents an immediate practical problem.
Right. How do I even know what tables are available to query?
Exactly.
If someone else handed me this local database file, or honestly, if I just haven't looked at it in 6 months, I am basically just guessing table names in the dark.
This is where we get to use one of my favorite structural secrets of the engine.
Yeah.
Every single SQLite database has a hidden system master table.
Really? A hidden table?
Yeah, it acts as an internal directory for everything inside that specific database file. By running a simple select query on a table called SQLite_master, you get an instant X-ray view of the entire database architecture.
Okay, but what does that X-ray actually look like? Are we just getting a list of table names?
Oh, it is much deeper than that. When you query SQLite_master, the engine returns a blueprint. It tells you the type of object, whether it's a table, an index, or a view. It gives you the name, obviously. But most importantly, it actually contains a column called SQI, which stores the exact text of the create table statement that was originally used to generate that object.
Wait, wow. So I don't just see that a table called transactions exists. I can actually read the exact schema.
Yes.
I can see every column name, whether it's an integer or text, and what the primary keys are.
Exactly. It's the very first thing you should do when exploring a new data set. Before you even try to pull metrics, you interrogate the master table to understand the blueprint of the house you are walking into.
That is incredibly powerful. But I guess that brings us back to the scenario we started the show with.
The crash.
Right. Let's say I interrogate SQLite_master. I find a table called historical logs. I look at the schema, it looks fascinating, and I get greedy.
I see where this is going.
Yeah, I type out select star from historical logs, and I hit run. But unbeknownst to me, that table has 50 million rows. What physically happens inside my machine in that moment?
Okay, so this is where we hit the collision between Datok's raw power and the web browser's security architecture. When you execute that query, Datok goes to your hard drive to pull the data. Modern local first applications use something called OPFS, or the Origin Private File System.
Right, I've heard of OPFS. That is a relatively new browser-native technology, isn't it?
It is, and honestly, it is revolutionary. Before OPFS, browsers really struggled to read large local files quickly.
Yeah, they had to load things into IndexedDB, right?
Exactly, which is notoriously slow and clunky. OPFS allows the browser to allocate a hidden high-performance chunk of your actual hard drive. The SQLite engine inside Datok can read and write bytes directly to your local disk with near-native speeds.
So it streams that data incredibly fast.
Blisteringly fast.
Okay, so if OPFS is so fast, and my laptop has 32 gigabytes of RAM, why did my tab crash when I asked for those 50 million rows?
Because of the V8 JavaScript engine. Your operating system does not actually give your web browser access to all 32 gigs of your physical RAM.
It doesn't.
Nope. Web browsers are designed as highly secure sandboxes. The specific tab you are working in enforces a maximum JavaScript heap memory size.
Wait, really?
Yeah. No matter how powerful your hardware is, this sandbox limit is typically capped between 1.5 to 4 gigabytes, depending on the browser.
Wait, so the browser kind of acts like a protective parent.
Basically, yeah.
It assumes that if a single website tab is trying to consume 10 gigabytes of memory, it must be a malicious script, or a cryptocurrency miner, or maybe an infinite loop.
Exactly. The browser's primary job is keeping your operating system stable. If it let a single tab consume all your RAM, your whole computer would crash. So it sets a hard ceiling.
That makes sense.
Now think about your query. You ask for 50 million rows. The local SQLite engine uses OPFS to fetch them from the disk at lightning speed.
Right.
But once they leave the disk, they have to be rendered in the browser. Every single row becomes a distinct JavaScript object in the browser's memory.
Oh, man. And 10 million rows means 10 million JavaScript objects dumped into that tiny 4 gigabyte bucket.
Yes. The browser's garbage collector panics. It tries to free up space, spiking your CPU in the process, but the incoming data is just too massive.
So it just gives up.
The heap fills up, hits the ceiling, and the tab instantly crashes with an out-of-memory error. the screen just goes blank.
So if the V8 engine is capping my memory, the only logical step is that I have to throttle the data I'm feeding it. I need to stop the data at the SQL level before it ever reaches the JavaScript layer.
Precisely. And the solution is incredibly simple. You must always apply a limit constraint to your custom SQL queries when you are exploring raw data.
Ah, okay.
Instead of asking for all 50 million rows, you add limit 1,000 to the end of your query.
That ensures the OPFS layer only hands 1,000 rows over the fence to the JavaScript engine.
Exactly.
And the browser renders it instantly. No panic, no crash.
You've got it. You use limits to build your logic, test your joins, and verify your columns. Once your custom logic is perfect, you write your aggregations, your shums, your averages, your groupings.
Right.
The database engine does all the heavy lifting down on the physical disk through OPFS, and it only sends the final summarized numbers back up to the browser tab's memory.
So you never actually need to load 50 million individual rows into the browser's UI. You just load the calculated result. That makes perfect sense.
It saves so many headaches.
So let's say we have done exactly that. We safely queried our data, we respected the V8 memory limits, and we generated some really insightful aggregate result sheets and charts. What is the next step? We need to move from writing code to actually telling a visual story.
This is where we shift from the custom SQL console to the presentation canvas. In the Analyze workspace, there is a tab called Plus Dashboard.
Okay.
Clicking it opens a completely empty grid. This is your blank slate. It's where you combine all those individual worksheets, pivot grids, and visual charts into one unified interface.
See, here is where it gets really interesting to me, especially coming from a design background.
Oh, yeah.
Yeah, the dashboard canvas isn't just a free-for-all whiteboard. It uses a structured 12-column responsive layout system. And when I first saw that, I instantly recognized it. This isn't just arbitrary math. This is a direct descendant of classic web design architecture, right?
It absolutely is. The 12-column grid is foundational to modern UI engineering. It borrows heavily from early grid systems like the 960 grid and massive front-end frameworks like Bootstrap.
Right.
It bridges the gap between data science and front-end web design.
But why specifically 12 columns, though? Why not 10? Humans love base 10 numbers.
It comes down to typographic flexibility and divisibility. You can't divide 10 evenly by 3 or 4. You end up with these awkward fractional widths.
Oh, that makes sense.
But 12 is highly divisible. You can split it in half, in thirds, in quarters, or in sixths. It allows for incredibly intricate, balanced, asymmetric layouts that scale beautifully no matter what screen size you are presenting on.
Let's ground that in some real-world dashboard strategies. If you were building a layout and you set a card to take up 1/4 of the width, it spans exactly 3 of those 12 columns.
Right.
I find that size is absolutely perfect for key performance indicators. You can line up 4 distinct metrics like total revenue, active users, churn rate, and cost cleanly across the top of the screen.
That is a classic executive layout. Then moving down the dashboard, you might want to show regional performance. You set 3 pie charts to 1/3 width each, which takes up 4 columns per chart.
And they sit perfectly side by side beneath your KPIs.
Exactly. And for the heavy hitters, you use the half-width option, which spans 6 columns. That is your standard go-to size for larger bar charts or deep comparative data grids.
And finally, the full width card takes up all 12 columns, completely dominating the screen.
Yes, you reserve that for massive timeline visualizations or wide, detailed financial tables where the user needs to scroll through extensive rows.
And the interface makes building this layout incredibly tactile, right? Like playing a game of Tetris or packing a digital bento box.
Exactly like a bento box. When you check a worksheet in the sidebar, it drops onto the canvas. You can just click, hold, and drag the card to reorder it dynamically.
Oh, nice.
If you realize your timeline visualization needs to be at the top to set the context, you just drag it up. Datok handles the responsive reflowing of the grid automatically.
So you are really curating a narrative flow. You're guiding the viewer's eye from high-level summaries at the top down into the granular analytical details at the bottom.
Beautifully said.
But, a truly great dashboard isn't just a static picture. It has to react to questions in real time. Which brings us to my absolute favorite feature, the global filters.
Global filters completely change the dynamic of a presentation. In that same configuration sidebar, you can designate a specific database field as a global filter.
How does that look for the user?
Let's say you add region as your global filter. It creates a unified dropdown in the top toolbar. When you select North America from that dropdown, the filter reactively updates every single card on the dashboard simultaneously.
Every chart, every pivot grid, every KPI, all pivoting instantly to reflect just the North American data.
Exactly.
And this is where the local architecture we talked about earlier creates a massive advantage. Because everything is running through that local OPFS storage layer, there is zero network latency.
None at all.
You aren't waiting for a cloud server 3 states away to receive your filter request, process the query, and send the HTML back to your browser.
The data is literally sitting on the solid-state drive inches from your keyboard. The update happens in milliseconds. It makes the data feel alive.
Wow.
You can pivot through different regions or product categories faster than your audience can even finish asking the question.
Which brings us to the final piece of the puzzle. The dashboard is packed, the data is safe, the layout looks gorgeous, and the global filters are snapping lightning fast. Now, it is time to actually show this to the boss or the client or the board of directors.
And this is where many analysts stumble.
Really?
The environment you present in shapes how your data is perceived. Nothing undermines the authority of a brilliant insight, quite like a cluttered software interface wrapping around it.
Exactly. If I am presenting to a VP of finance, I don't want them staring at my SQL navigation tabs or analyzing the left-hand configuration sidebar or, getting distracted by my browser's bookmark bar.
Right.
I want them completely immersed in the story the data is telling. That's why datok includes the present mode button right in the top toolbar.
Clicking present mode is honestly like dimming the house lights in a theater. It completely hides all the mechanics of the workspace.
So it all just vanishes.
The sidebars disappear, the toolbars vanish, and the 12-column dashboard canvas expands natively to fill every inch of your display.
It transforms a raw data query environment into a sleek, professional web application. It completely removes that clunky feeling of showing someone how to use a piece of software and replaces it with a polished analytics product.
If we think about the psychology of a business meeting, when an interface is cluttered, executives inevitably get distracted by the buttons and the menus.
Oh, all the time. What does that button do?
Exactly. They start asking questions about the tool itself rather than the business metrics you are trying to highlight. By deploying present mode, you command the room. You remove all visual objections and force the focus purely onto the insights.
And it isn't a permanent commitment. If someone asks a highly technical question that requires you to actually tweak the underlying SQL query during the meeting, you simply press the escape key. You seamlessly exit present mode, drop right back into the builder interface, adjust the code, and hit present mode again. It's totally fluid.
It perfectly bridges the gap between the deeply technical, unpolished work of writing manual SQL and the highly curated world of executive communication.
So what does this all mean for you, the listener? Let's quickly recap the journey we've mapped out today.
Good idea.
We started in the weeds, taking control of our raw data using select-only custom queries, ensuring our local databases remain untouched and protected by the system's architecture. We learned how to use the squite_master hidden table as an X-ray to expose the schema of any dataset. We tackled the physical reality of JavaScript engine limits using limit constraints to throttle our OPFS data streams and keep our browsers running smoothly.
A crucial step.
And finally, we took those massive, complex aggregations and placed them into a highly responsive 12-column dashboard layout that we can present cleanly in full screen.
It is a truly comprehensive workflow. It proves that you don't need a massive cloud infrastructure to build powerful reactive analytics. You just need to master the tools and the constraints of your local machine.
My direct call to action for you is this. On your very next project, once you have your custom queries dialed in and your charts built, take 5 extra minutes.
Just 5 minutes.
Drop them onto the 12-column dashboard canvas, set up one global filter, and hit that present mode button. See for yourself how much cleaner and more authoritative your data narrative feels when the interface simply fades away.
I think that is an essential challenge for anyone looking to level up their communication. And I will leave you with this final thought to mull over.
Let's hear it.
If your dashboards are powered by entirely local data, completely freed from cloud latency, server timeouts, or internet speed bottlenecks, how might that instant, zero-latency interactivity fundamentally change the pace at which your team can ask questions, spot anomalies, and make decisions during a live, high-stakes presentation?
When the tool gets out of the way, the conversation moves incredibly fast. That is a fantastic question to end on. Thanks for joining us on this deep dive, and we will catch you next time.